Hello students, in this session we will discuss about data encapsulation, abstraction and data structures introduction. First one, what is meant by data encapsulation? So encapsulation refers to the process of combining data and functions into a single unit. Here the main advantage, with the help of encapsulation, the data is not accessible to outside world and it can be accessed only through the functions which are placed inside the class. So here these functions provide an interface between objects data and the program. Hence sometimes encapsulation is also referred as data hiding or information hiding. So when we observe this process, in class concept, data and functions are combined into a single unit. Hence, with the help of class, it is possible to achieve encapsulation. Then, data abstraction. So abstraction refers to, it is a mechanism to represent essential features without including their background details or explanation. So when we observe this, while designing a class, initially the class is declared only with data members and member functions. Later we define the definition of the member functions. Hence class concept is used to achieve abstraction. Okay. Now data structures is important thing. Now what is meant by data structure? For this, different authors gave different definitions. Here let me consider two definitions. First one, logical or mathematical model of a particular organization of data is called a data structure. Or we go for one more definition. The class of data that can be characterized by its organization is known as data structure. Here, when we observe these definitions, all these definitions focuses on two terms. One is how the data is organized, so that how we implement operations on those data members. So data and functions are referred as data structure. In general, data structures are classified into two types, like linear data structures and non-linear data structures. First one, linear data structures. In linear data structures, data is organized in a sequence. That means it is in linear fashion. So when the data structure is a linear data structure, there is a relationship between adjacent elements of the list. So let me consider any two adjacent elements, they maintain some relationship. It is possible only in linear data structures. Let's say examples: arrays, stack, queues, linked list. So all these data structures are linear data structures. The second one, non-linear data structures. In non-linear data structures, elements are arranged without any sequence. That means they are arranged in non-linear fashion. In non-linear data structures, if we take any two elements, adjacent elements, there is no any relationship. Here the examples are trees, graphs, sets, tables, etc. So these are all non-linear data structures. Then applications of data structures. So data structures are used in different application areas such as compiler design, operating system, numerical analysis, computer graphics, artificial intelligence, simulation, etc. Abstract data type, which is simply referred as ADT. So abstract data type is a specification that stores data types and operations performed on the data type values. So here it just shows a specification without any details of implementation part. The examples: array ADT, stack ADT, queue ADT, etc. Now, first we discuss linear data structure concepts. The first one, arrays. Students, you are all familiar with arrays concept in previous semesters. So array means it is a collection of homogeneous data elements. Those are stored in successive memory locations. So while defining an array, we must specify the array name followed by one or more subscripts in which an integer value is placed inside the subscript. Here, the subscript defines the dimensionality of the array. Hence, based on the number of subscripts used with the array, it can be classified into three types like single dimensional arrays, double dimensional arrays, and multi-dimensional arrays. Here, the first one, single dimensional arrays. Single dimensional array can also be known as one dimensional array. So when we observe its definition, let M is the size of an array. Now a single dimensional array can be defined as it is a collection of M homogeneous data elements. Those are stored in M successive memory locations. Now observe the general format of a single dimensional array. It starts with the data type followed by array name, then within one square bracket size. Here, data type specifies type of the elements stored in the array. Array name specifies name of the array that follows same rules as a valid identifier. Size indicates maximum number of elements which are possible to store inside the array. Let's example int x of 5. So x is an integer array which is capable to store 5 integer values. Now it shows the diagrammatic view of a single dimensional array. So here 5 locations are available and all locations are referred with its index values like 0, 1, 2, 3, 4. For each and every location there is an address. Now all locations shared a common name as x. Now in single dimensional array, to access any location we use the format like x of index value. So if you are interested to access 0th index element, then it can be accessed as x within square bracket 0. If you are interested to access the third location, now we place x within square bracket 3. In such a way, it is possible to access those locations. The second one, double dimensional arrays. So double dimensional array is also known as two-dimensional array. It uses two subscripts. So definition: let m is the row size and n is the column size. Then a double dimensional array can be defined as: it is a collection of m into n homogeneous data elements. Those are stored in m into n successive memory locations. Let's example. Now first observe the general format: data type space array name with a square bracket size 1 within another square bracket size 2. Here data type specifies type of the elements stored in the array. Array name refers to name of the array that follows same rules as a valid identifier. Size 1 represents row size that indicates number of rows. Size 2 represents column size that indicates number of columns. In general, double dimensional format is used to represent the given array elements in terms of matrices. Let's example int x of 3, 4. For this, the diagrammatic representation should be in this format. Here memory allocation, it consists 3 rows and 4 columns. So this one, double dimensional array. Third one, multi-dimensional arrays. Multi-dimensional arrays uses more than 2 subscripts. So definition: let m1, m2 and so on mn are the sizes of an array. Then a multi-dimensional array can be defined as: it is a collection of m1, n2, m2, n2 and so on into mn homogeneous data elements. Those are stored in m1, n2, m2, n2 and so on into mn successive memory locations. This one syntax: data type array name within square bracket size 1 within another square bracket size 2 and so on within another square bracket size n. Here also data type specifies type of the elements stored in the array. Array name specifies name of the array that follows same rules as a valid identifier. Size 1 represents number of tables. Size 2 represents number of subtables and so on. Size n-1 represents number of rows and size n represents number of columns. So in case of multi-dimensional array, memory is allocated in terms of collection of tables. Now we define array identity. Now we observe the abstract data type for an array. So abstract data type consists data members and member functions. Here those are referred as instances and operations. Here instances are, it is a collection of same type of elements. Those are stored in successive memory locations. Whereas the supporting operations are create, insertion, deletion, get, set and display operations. Create operation is used to create an array with specified number of elements. Insertion operation is used to insert a new element item at the specified position POS of the array. Deletion operation is designed to delete the specified position POS element of the array. Get function is used to return the existing element at the index position of the array. Set function is designed to replace the value at the specified index position of the array. And display function is used to print elements of the array. So this one, array abstract data type.